In this video lecture, we'll present a quick introduction to static variables in classes and give an example of using them to implement an object counter. Okay, let's get started. This is kind of a bonus topic and not something we've currently got implemented in our person class, although we may do something with it later on. In past lecture materials, we briefly discussed the idea of static variables or class variables. These are variables which belong to some class as opposed to individual object instances of that class, as is more typically the case with regular instance variables. Such variables are designated by the use of the static keyword in their declarations. The key point is to realize that the entire class and all objects of that class share one common copy of a static variable. Static variables are created only once when the Java virtual machine initializes any class. So therefore, static variables can exist before there are even any object instances of their class. Also, static variables can only be accessed using static method calls. They cannot be accessed by any individual object of their class, nor by any of its methods. By way of review, remember that we also have static methods, and these are methods which again belong to the entire class rather than to any individual object instances of the class. They are also designated as such using the static keyword, and they are called using the name of their class, not using dot notation following the name of some object. Some examples of static methods we've already seen are all the methods of the math class and JOption pane for performing I/O using pop-up GUI dialogues. Here are the three key restrictions upon static methods. Static methods can reference only the static variables of their class. Static methods can directly call only other static methods of their own class. Remember that in a previous program assignment, if the main method is calling other methods directly by name, those methods too must be static. And static methods can't use the object reference this because of course that keyword pertains to some specific object instance. Here's a visual example of what we mean by contrasting static variables to regular instance variables in a class. You can imagine that there are two completely unconnected sides of data in this class called myClass. We have this instance variable instavar and this static variable statvar, as we see here. Each created object of type myClass will have its own specific value for instavar, as we see here on the bottom, and we can use the accessor method applied to each object to retrieve any of these values, as we see here on the left. But by contrast, this static variable belongs to the class as a whole and not any specific object. We can still retrieve the value using an accessor method, except that now the accessor is called statically using the name of the class as we see here. Furthermore, this one single static value is shared by all object instances of this class. Here's a code application example which demonstrates a typical use of a static variable. Here we're using a static variable to implement an object counter. This class has two private instance variables, but then it also has a static class variable count as well, which is initialized to 0. Every time we create an object of this class, we call one of these three constructors, and inside the default and full constructors, we see that we increment the count static variable. We actually do the same thing in this third constructor as well, but we do it indirectly here through reliance upon the this call, which as we recall is simply a call to this default constructor. What we don't do is increment the count here because it's not needed, and besides this would wind up incrementing the count twice. Then to get to this static count variable from the outside, we'd use this accessor down here, and notice that this is a static method. Our count variable has a 0 value before any objects even exist, so therefore this method must be callable independent of any objects, hence the static designation. Now keep in mind that this class is not really complete, such as we've seen for the class we created from scratch. I've intentionally kept this a little simplified just for demo purposes. But every time we create one of these objects, we up the count of them. So now let's see how to use this class. By the way, this example is class_object_counter.java, and you should have a look at its code walkthrough once you are finished with this lecture video. Here's an example of how to use that object counter. This client program is actually the main method test driver found at the end of the preceding class. But this could just as well be a client application in some other file. On each of these four calls to the count accessor, we see that it's called statically using the name of the class. So in this first one, we correctly show a count of 0 down here, But more significantly, we're doing this before any class object counter objects even exist, so we can't use object.method notation. And that's why this has to be a static method. In each of these statement groups, we're creating a new object, printing it out, then printing the updated count of objects created. And down here, we see the output results. No objects at first, then 1, 2, and 3 objects. Again, because count is a static variable, we have to access it statically, and it belongs to the class as a whole, not to any individual objects. To finish this topic up, please view the short code walkthrough for classObjectCounter.java, which you'll find in the usual place. Open up this file in JGrasp so you can follow along. Okay, so that's it for now on static class variables. And now you know how to set up an object counter, which is something we may add to your class a little later on.